Okay, I'm going to briefly talk you through question number 6 in your free response packet. So this is 2003 test, question number 3, which I believe was a no calculator question. Everything on here is easily done without your calculator. There's a little bit of multiplying things and adding things up, and that's about it. This is going to be pretty quick, so I'm assuming you've already looked at it, and I'm just going to kind of walk you through. I've got the rubric here, and we can figure out where you would have gotten points and what you should have essentially been doing. Part A is a classic question when they have a table of values and you don't have a known function, where they ask you to approximate a slope, r prime, approximate a derivative at a particular point. So as soon as I'm seeing r prime, I'm thinking derivative, but I don't have a function, like I said, to take the derivative. So in this particular case, the best you can do is go over to your table of values that you have. So let's zoom in here a little bit. They're asking you to find or approximate the slope at 45. Time equals 45. Well, it doesn't look like we have that, but we do have 40 and 50 would be the closest value. So they want us to take these 2 points, if you will, t comma r of t, or x comma y, and think slope formula from Algebra 1 class. So I'm literally going to do y2 minus y1 over x2 minus x1, where this is y1, y2, x1, x2, and subtract your y's to get your change in your rate of fuel consumption per time amount. Put that into the correct notation of the problem, and here's what it would have looked like. Let's go down here to part A, and there's your y2 minus y1 over x2 minus x1. Notice the units here. To get the 2 points for this part, excuse me, you would have had to have the difference quotient would have gotten you a point, and then the second point here, excuse me, second point is getting the answer with the units, gallons per minute squared. And that's a little tricky, but your original r function is a rate. So r prime is actually like your acceleration when you're talking velocity acceleration, because you're finding the rate of change of the rate of fuel consumption. So that's where the minute squared come from. Going back up to B. I found B to be the trickiest part of this question, to be honest, just because they start talking about r double prime, and I don't even know where r double prime is coming from. So if you take it back to what we know in calculus, rate of fuel consumption is increasing fastest at time t equals 45. So visually, I'm seeing that on the graph. If you're trying to conceptualize what's happening here, they're saying that the slope of your R graph is the steepest at 45, and that makes sense if you go over to your graph here. That would have been right about where I drew that tangent line. So the rate of change, again, your R graph, what's graphed? We're really looking at the derivative there, but they're defining that as your original R. R prime is greatest at time 45. They want to know what's happening to R double prime. So what I'm going to do is I'm going to picture the graph of r prime, except I'm not going to really picture it all. I'm just going to pick up on the fact that if this is true, that means r prime is at a maximum at time 45 minutes, because that's what has to be happening if it's the greatest. So if r prime is at a maximum, now let's make that my function, and I want r double prime as the derivative of r prime. What's happening? What can you tell me about the derivative when you're looking at a maximum on a graph? Well, you can all answer that question. Derivative has to be 0. So here's my r graph. I honestly have no idea what my r graph looks like. Sorry, there's my r prime graph. I don't know what it looks like, but I know that at time 45, r prime is at a maximum, and therefore my derivative, which is r double prime, has to be 0. Oops. And that's me not doing a ton of extra work, because I don't really care. I meant to put 0 there. I don't really care about drawing the whole graph out. But what I care about is interpreting that as that has to be 0. Okay, let's get that graph out of there. And when we go down to B, B was 2 points. They gave us a point for saying 0 and a point for the reasoning saying something about r prime has a maximum. Part C should look very familiar. Approximate the value of the integral of r of t from 0 to 90 using a left Riemann sum with 5 subintervals. No surprise, based on the table they gave us exactly the right amount to do 5 subintervals. Sometimes they have you start and not go the whole way. In this case, they do want you to go all the way from 0 to 90, which is everything in your table. And then they ask, is this numerical approximation less than the value? And explain your reasoning. So 2 great questions. The first one's very straightforward. I'm just going to show you the rubric there because we should be able to do that at this point. And they're giving you one value for setting that up and getting the value. So take a look. Please make sure you can follow that. I'm surprised that they didn't put units there. The units, because it's fuel consumption in gallons per minute. Remember that the integral is giving us the accumulated rate of change. So that's giving us the number of gallons. So I would have added this to their answer. That's the number of gallons that have been used in the first 90 minutes. Yes, this approximation is less because the graph of r is increasing on this interval. And this would be a great follow-up from your journal question number 1 that you guys were working on. If you think about what's happening with your function, I would just start drawing. So we know, based on the table here, that my r function is increasing. I'm looking to see if it says anything about continually increasing. Strictly increasing function. Okay, so we can't necessarily say just because all the numbers in my table are going up. But it does say right here for me that it's strictly increasing. So I'm just picturing what could that look like if I've got an increasing function. Well, it could look like this. Or it could look like this. Basically, it could be concave up or concave down. And if I start drawing in my rectangles, left-hand rectangles would be go to the function and then make a rectangle. Use the left-hand height of the rectangle, if you will, for the value. And it doesn't matter if it's concave up or concave down. My rectangle approximations in both cases are slightly under. I've got that extra value that's not accounted for that would really be part of my area under the curve. So I guess what I'm hinting at here is that the over or under approximation, the fact whether or not your approximation will be over or under when you're talking left-hand rectangles, and I think it would make sense to extend this to right-hand rectangles, has everything to do with whether your function is increasing or decreasing and nothing to do with concavity. That was 2 points, leaving us 3 points for part D. So part D, I guess I should go up to the question. It says, explain the meaning of the integral and explain the meaning of integral with 1 over b in front. Indicate units of measures for both answers. So that's interesting because I would have thought that would be 2 points. Let's see where they're getting the points for. They're giving you 1 whole point for units, which is pretty awesome. So here's where we're going to go back to what I already said in part C. The integral from 0 to b, now they've just got this generic b up here. Don't be afraid of that. Just make sure you don't say 90 in there or a specific number. It's the total amount of fuel in gallons consumed for the first b minutes. So like I said, I already told you that the integral of a rate is giving us an amount. And that's my general rule of thumb I use. They gave me a rate function. Integral is an amount of something, in this case, amount of fuel. And then when I put the 1 over b in front, you should be recognizing that as the average value theorem. We could have phrased it the way they did. I probably would have just written is the average rate of fuel consumption. And I would have probably left out this value, and that would have been fine too, because it is the average value of that function, which is rate of fuel consumption. And then units, of course, are gallons per minute. Just a quick reminder of how we're getting that. This we just said comes out to be gallons because that's the same as that. So I have some amount of gallons, and then I'm dividing by b is really the difference between b and 0, this amount of time traveled. So I'm dividing by minutes, and that's where I get my units. 1 over minutes times gallons. And I'm putting those underneath. Okay, so hopefully that helps you. I'm going to stop it at 10 minutes because that's already a long video. But hopefully that helped you to kind of understand where you should have gotten your answers and hopefully feel good about where you got your answers.